Yeah, my name is Audrey Brouillet. I work at the Institute of Research for Development in France, in the city of Montpellier. I'm currently a postdoctoral researcher, and I mostly work on impacts, multi-sectoral impacts of global warming. So both in the observation, so historical observations, and also in future projections. And today, thanks to Agnès here, I'm going to present you some results my colleagues and also I contributed to about the impacts of global warming, and more specifically, what do we know for real about impacts of climate change in Africa and specifically on agriculture, and also how can we know this is proper impact of global warming, so how can we attribute this impact. So quickly, today's summary, what I'm going to talk about and I will try to keep the time up. So first part about impacts, I'm going to present the impact of climate change, what we currently know, also the uncertainties in Africa, and also something important, I hope, where to find such data. So you here present today can explore by your own such data, so raw data and also facilitated accessible data. And in a second part, we'll talk about detection and attribution, that is a specific research field in climate sciences, about the attribution of an event or trend to global warming and to human influences. And I chose to keep the questions by the end of each separated part, so we can discuss and not wait for 1 hour to see your questions and interesting discussions. So let's start right now. As you may know, there is a global warming that is now unequivocal, and that's the IPCC who is telling it this way. To illustrate this fact, this statement, here I present you a graph of the anomalies of temperature for the past 2,000 years. So from 2000 to at the beginning, well, yeah, in mid 19th century, this is reconstructed temperatures, temperature anomalies, and since the mid 19th century, it's observed temperatures. What is visible, what we can see on this kind of graphic is that the past decades, the past centuries warming is unprecedented compared to the 2000 years that we experienced lastly. So this warming is unprecedented. And this warming has also already reached and overcome the warmest warming, the warmest multi-century period over the last 100,000 years that you can see here. This is the range on the left side of the graph. This is the range of the warming and the changing in temperature over the last 100,000 years. And what we can see on the recent decades here, we are currently almost here on the top side of the black curve. We have already overcome this possibly warming that we have experienced in the past 1,000 years. In terms of maps, that's probably maps you've already seen from the IPCC, the Intergovernmental Panel Climate Change Experts. So the last reports were provided last year in 2023. Here you can see the current observed change at global scale here on the top left side of the graph. So this corresponds to the global warming. So the global warming is at 1 degrees, but we can see there are regional differences, particularly in the North Pole and the South Pole. So this is the current observed change. The same is provided at the right side of the panel. The right panel, sorry, of the graph here. It's the same, it's not the same, but it's the change at 1 degree warming, but simulated by the climate models. As you may know, scientists, climate scientists use both observations to record and to have an idea of what is visible, what is observed in terms of climate on Earth, and in order to understand what are the linkages, what are the feedbacks, what are the relationships between all the components of the atmosphere, of the ocean, all the components within the climate systems, they are able to simulate, to create dynamical models to understand and try to reproduce the climate, both to understand it as I just told, but also to try to sorry to project to know what's going to happen next in the near future and the long-term future. So this is the simulated warming, global warming at 1 degree. So there is some differences with the observed one. The model never tells the absolute truth, but try to reproduce and understand it. And using the same kind of models, but simulating changes with an increasing warming, so a warming at 2 degrees on the bottom left and warming at 4 degrees on the bottom right, we can see how hot the temperatures are gonna be. And once again, a mean 2 degrees warming here on the left means higher warming on the North Pole specifically. At 4 degrees, it's starting to get really, really warmer. We project climate models project a warming at over 6 or 7 degrees in the North Pole. Even if all the globe, the average of warming over all the globe, it is at 4 degrees. So how about Africa? So since few years now, what has become very interesting as well as really important, and it was raised way before it was done, an entire chapter is dedicated to Africa in this IPCC synthesis about climate. This is for the last report, so the 6th version. It's chapter 9. This chapter 9 specifically describes key risks to global warming. It also describes all the studies about how the vulnerability, the exposure to global warming, to such risks is multidimensional and complicated to study, and also needed to be studied because there is significantly less studies on this continent and over all these related regions compared to other regions in the world, for example, Europe. Here is the map of Africa and the corresponding regions that are defined in the IPCC reports, the north, the west, central, east, south, with some paragraphs about more specific countries and regions, of course. But yes, these are the 5 regions on which the major conclusions are drawn in this report. So in terms of observed trends in Africa in climate related to climate trends observed in Africa. Oops, sorry. The two major climate variables that are usually studied are temperature and precipitation. So here are the observed trends for both over 1980 until 2015. The value correspond are in unit per decade, so in degrees per decade for temperature and in millimeters per decade for precipitation. For temperature, we can see some spatial discrepancies. We can see that the warming is faster, or it's warming faster or more in the near Egypt and in northeastern of Africa. Some regions are shown to be not really warming. This is the case right over here and the slight part here. But it also corresponds to regions that are not significant related to the data and the studies that have been conducted. So there is a real need to study this part of the world. There is a real need to provide observations here. In terms of precipitation, it's also really, really different among the regions, among the countries. first, there is a lot of places that are not significant according to the data and the studies. So it is very complicated to draw conclusions in terms of trends. For some part, for example, in West Africa, we have significant trends, wettening, especially in the western part of West Africa. But for many places, including Central Africa or Southeastern Africa, we do have drying trend, but the IPCC and actually the climate scientists are not confident enough in terms of trends for this specific climate variable. So here is it's not that complicated, but it's kind of, there is a lot of information. So I'm going to take some time on this specific graph that provides information on impacts, climate-related impacts in Africa. For each regions, the smaller regions that are provided here on the map, on the top left map, you have the corresponding trends in terms of impact per type of impact per sector. To give an example, for every line you have here, you have all the regions that are drawn right here, that are illustrated right here. And for all columns here, you have all the type of impacts, the type of extremes that are observed and projected as well in Africa in each region. When you have a triangle pointing to the top, it means that the given impact increase. So for example, for extreme heat right here, for all the regions, we have a high confidence, the legend is at the bottom, a high confidence of increase. For cold spell, at the opposite, we have a high confidence of decrease of this specific impact. What is important to see here is that some some sectoral impacts, for example, temperature right here, the first four columns right here are significant, and we can see significant trends of increase of temperature, so of decrease of cold event, so cold spell or event of frost right here. Same goes for coastal and oceanic type of impacts right here. So the sea level, the coastal flood, for all regions, mostly all regions right here, we have a high confidence in increase of such impacts. But for almost all other impacts, or most of them, we have a very low confidence in the trends. We have a low confidence in the conclusion, once again, we can draw, particularly for precipitation and rainfall events and trends right here. We are not sure for some, for example, aridity in Sahara, we are not even sure about the sign of the change. So also there are emerging and an increasing number of studies on this particular extremes, on this particular on this particular region and this particular kind of extremes. There is still some challenges and issues to assess the impact of climate change in Africa. For what we can say and what we can know, and specifically on agriculture. So first I will start to talk about impacts of global warming in Africa on crop yields. We are able to simulate crop yields depending on various levels of warming. So here I present you for different crops. So the three major staple crops. Here is an example for maize. And for Northern Africa, so you have this kind of boxed plots for all regions, all crops, and different warming level. And the difference between the solid, the full colored box plot and the empty box plot is that whether we take adaptation measures into account. So Northern Africa on the top, Western Africa at the bottom, maize on the left, rice in the center, and wheat on the right. Sorry. What we can see for all these regions, for the two regions, for the three crops, is that there is a decrease. It means that the values are expressed in percentage of anomalies relative to an historical reference. I think it's 1980, 2015, if I am correct. So all the values, almost all the values, according to the simulations, are below zero. So it means a decrease of the crops yields relative to the warming. But the warmer we get, it's not that clear that the warmer we get, the lower yield we get. For example, if we look at the first Northern Africa yield impact in terms of maize right here, we do have lower crops when we are at 2 degrees warming or 4 degrees warming right here. But for example, for 3 degrees warming, we have the same amount of loss than at 2 degrees warming. So I think, I mean, I don't not thinking. The one explanation behind that is that the crops reach a certain threshold in terms of limitation due to global warming. There is a certain limitation after in a certain threshold that the crops cannot really reach in terms of loss. This is the same graph, the same box plot for two other regions, so Eastern Africa on the top and Southern Africa at the bottom. Once again, there is for almost all regions and almost all crops, the value are below zero, so it means a negative yield impact. And without adaptation, that I forgot to talk about on the slide before, but without adaptation, so in full colors right here, the loss is more important. It's the global warming has a even more negative impact without adaptation. But even with adaptation, for example, here for maize, Eastern Africa, so the whitey colors right here consider adaptation. Even with adaptation, if the warming is too strong right here, the loss will still be observed. A loss will be observed. So the warming we get, the less efficient adaptation measures will be in terms of agriculture, and that works for other crops and other regions right here. So really quick conclusion or really quick key message here. Crop yields are simulated to decrease according to climate models and also crop models in Africa. And for major staple crops, obviously there are some differences and discrepancies depending on the crops you look at. The adaptation potential to counteract yield loss because of the global warming is reduced when you increase the global warming rate, at least for rice, maize, and wheat. And few numbers on average, so really averaging the regions and all the crops, there is depending on the warming level, there is a yield loss from minus 30%, 10%, so relative to 2005 levels for 2 degrees, so minus 30 to minus 10% if the climate is warming by 2 degrees, and for almost minus 50% to minus 20% if the climate is warming at 4 degrees. In terms of fisheries that are not really included in agriculture, but they are still included in food supply, in food production. For marine fisheries, many African countries are really dependent on this type of food production. So these maps represent how both impacts of global warming and the dependence on marine food are related. The green map shows per country how each country is dependent on on marine fisheries, on green here. The yellow maps shows the global warming impacts depending on the global warming level. so 1.6 at the top and 4 degrees, plus 4 degrees at the bottom. And the purple show you the linkage, how both are interconnected. So both where there is a strong dependence on marine fisheries and also a severe warming, severe possible and simulated decrease of marine fisheries availability, a decrease in fish availability. So lots of Western countries, Western African countries are are impacted by such both linkage. For example, Mauritania here, you have Center Africa right here, Cameroon, Senegal as well, for a warming of 1.6 degrees. And if you increase the number, you increase the warming, more countries are even more affected by such negative or at least risky dependence, linkage between dependence of marine fisheries and also impacts of global warming, adverse and negative impacts of global warming on such fish availability. Same goes for freshwater fisheries. So now it more include countries inland of Africa. So many countries are strongly dependent on such freshwater fisheries. You can see the map on green here. On yellow, the impact, the adverse impacts of global warming on such resources of fish, and on the purple, the same goes for the dependence and the combination of both dependence and adverse global warming impacts, and which is also yet interesting in terms of results, but really a risk for local population during upcoming years and upcoming warming levels, is that some of these countries are both affected by an increasing risk for marine fisheries and also an increasing risk for freshwater fisheries. So really reducing what is possible in terms of measure of adaptation and changing the supply of food in terms to adapt to global warming. So yeah, this was for fisheries. And for livestock, there is a lack of studies in terms of impacts of global warming on livestock. Most of the studies focus on how heat stress can influence, well, not influence, but affect and impact livestock. And other kind of studies are very local, which is complicated to draw a conclusion over all Africa or even over a specific region, for example, South Africa or West Africa. So there is once again a need for investigating such questions. There is still some data sets that are available to combine and investigate how severe heat stress for livestock can affect animals in Africa. So for example, here I present you the historical risk of the heat stress over the continent joined with the historical exposure of cattle. So this is the example only for the cattle in terms of livestock. So there is obviously other animals that are raised, chicken, goats, sheep. What we can see on the right side of this graph is that you have both severe heat stress in red. So the more red you get, the more severe heat stress you experience. And the bluer you get, the more animals, the more cattle density you have as well. So the darker you get, the combination, the exposure of cattle to severe heat stress you get. This is the maps for historical values. So the years are here. And when we project such heat stress according to different levels of warming, this is the maps we obtain. So warming at 1.5 on the left and 3.75 on the right. So still the same heat stress indicator, severe heat stress indicator. So combining this with the gridded datasets of livestock right here provide us thus a risk in terms of livestock and in this specific example of for cattle to be exposed to such severe heat stress. So now in terms of impacts, I'd like to present you on where you can find such data, such data sets when one is interested to explore in himself such data, such climate information. There is a lot of websites that provide different kind of services in terms of climate data, and I'd like to present at least one of them. May draw a list of few of them, but specifically present you one of them.